Welcome to Lesson 100 of Saxon Maths Course 2. In this lesson we're going to talk about estimating square roots and a little bit about irrational numbers. We're going to determine which consecutive integers a square root is when we have a non-perfect square root and where it falls between. We're going to estimate a decimal value for the square root of a non-perfect square, and we're going to show those estimations on a number line. Okay, so if you were asked to come up with the two consecutive whole numbers between the square root of that 200, the square root of 200 falls between. So how would you do that? Well, let's take a look at that. Well, you might first guess that the square root of 100 is 10, and the square root of 200's got to be higher than 10, so you might try 20. And you come up with 20 times 20 is 400, so 10 and 20 is too big. 20 is too big, so then you might try 15 by 15, you see that's 225. We're getting really close, so 15's better, but it says consecutive whole numbers, and 10 and 15 aren't consecutive. So then you might try 14, and you see that that's 196, and that's a little bit too small. But 14 and 15, they are consecutive numbers, so we can know that the square root of 200 falls between 14 and 15 if we were to answer that problem. Now, most of you, if you saw this problem, you'd immediately want to just grab a calculator. But to do that, you're going to come up with an 8-digit number, and it's not going to help you get the two consecutive whole numbers. It doesn't want the exact square root of 200, which you'll see you're not going to find. Okay, so these counting numbers, we've got counting numbers that are perfect squares. We've got 4, 9, 16, 36, 64, and you'll recall that the square roots of a perfect square is an integer. So the square root of 25 is 5, the square root of 36 is 6. But what's the square root of 29? Well, we know it's going to fall somewhere between 5 and 6, because this falls between 25 and 36. So we can know that it's going to be somewhere between these two, and we also know that it's not going to be exactly halfway, because 29 is not halfway between 25 and 36. So we're getting a little bit closer. We're estimating, but we can know that it falls between 5 and 6. If we are asked to narrow it down even closer than that, we could do that with decimals by trying 5.4 times 5.4 and getting 29.16, and 5.3 and 5.3 and getting 28.09. So now we know that the square root of 29 falls between 5.4 and 5.3. But if we were to take a calculator, we'd quickly find by plugging it in that the 8-digit answer would be 5.3851648. But the number 29 is a number that can't be expressed exactly as a decimal or a fraction, and therefore we call that rational. It's not a rational number, it's an irrational number. So, and we know that an irrational number is a number that can't be expressed as a ratio of two integers. Like 5 is rational because you could put a 1 underneath it, right? So that's rational. An irrational number, you can't do that. You're unable to do that. But yet 29 does have an exact length, just like in this example here. If we take our formula a squared plus b squared equals c squared, we can take, let's make this a, leg a, and this leg b, and the hypotenuse is always c. So 2 times 2 is 4, plus 5 is 25, so we add those together. That is 29. So, but there's not a 29 is not a perfect square, so our answer would be the square root of 29 centimeters. All right, so let's take a look at these number lines, and we're going to let you try to do a couple of calculate some missing parts on a triangle. So, where do these go on this number line, and are they rational or are they irrational? Let's start with the rational irrational part. Which of these are irrational? Which of these cannot be expressed as two integers? Hopefully you said these two right here, because those cannot. Pi is the approximation. It's not equal to 3.14. That's just something that we use. But these are rational. Okay, so I'll take out your low-hanging fruit. There's your negative 1/2. Can you place the other 3? I'm sure you can. Here's your 2 and at 0.3 repetend. Here's pi at 3.14. And we know that square root of, if one time the square root of 1 is 1, the square root of 4 is 2. So square root of 4, square root of 1. So we know that 2's got to go somewhere between these. So it's going to go right there. And it's going to be closer to the 1 than it is to the 2. All right, get the idea. I know it's a little bit new, but you'll get the hang of it. Okay, so let's just see if we can do a couple of these. Remember that you can have an answer that's a square root. So let's go ahead and pause the video and see if you can figure out what y is in both of these. Okay, so let's go ahead and start with the top one here. We've got let's go ahead and make our legs, right? Here's leg A, here's leg B, and here's the hypotenuse, and that's C. So we've got a squared plus 25 equals 100, because I've squared this 10, right? And I squared this 5. So what a squared plus 25 equals 100? Well, it's 75. So our answer to A is going to be the square root of 75, because 75 is not a perfect square. All right, let's try the second one here. Hopefully you did that too. Here's A, here's B. Okay, so A squared, we don't know what that is, that's missing, plus B squared, which is 1, equals 4. Well, what plus 1 equals 4? Well, it's 3. So our answer to y on the second one is going to be the square root of 3. Okay, that's how we write the answer. I know that's new, that's foreign to you. It's a new concept. We're going to get lots of practice doing these, so don't be discouraged if you don't understand it. Ask me some questions in class tomorrow. Here's your TIDs. Get them done, send them in tonight, and like I say, you know what you don't understand, we'll practice it together in class. Thank you for watching the video, and we'll see you tomorrow.